Do you see my screen?
Yes.
Okay, excellent. Now, remember that yesterday we talked about rational functions. Of the form f of x equal to ax plus b divided by cx plus d. So for any rational function, we want to identify the horizontal asymptote, vertical asymptote, and then using that, we are going to draw the graph, okay? Vertical asymptote? Yeah, I tell you.
Oh, okay.
I tell you. So
that's some kind of like information from grade 11. Like it was, I mean, yeah.
that's fine. So the vertical asymptote is basically the zero of the denominator. So let me write it. So the vertical.
Is it the restriction?
Yeah, the asymptote. So for finding the vertical asymptote, you have to set the denominator equal to 0. So that means when cx plus d is 0, so c, d, a, b, they can be any number. So what I'm doing is general, very general form. So cx plus d equal to 0, then it follows that cx equal to minus d, therefore x equal to minus d over c. So x equal to minus d over c is a vertical asymptote. So x equal to minus d over c is the equation. So it's a vertical line, right? Why? So this is why it's called vertical asymptote, because it's a vertical line. And the reason why we call it basically asymptote means a line so that the graph of a function approaches that line. So it's either a vertical line or a horizontal line. So here it's a vertical line. So the graph of this function approaches this line when x goes to approaches minus d over c. So I will show you in more examples. But this is the vertical asymptote. Now, once you have the vertical asymptote, then you can find the horizontal asymptote. So the horizontal asymptote is basically the value of y, or f of x, when x goes to infinity. When x goes to infinity. So in order to find the value of this when x goes to infinity, if you factor out x from the top and the bottom, so you get x times a plus b over x divided by x times c plus d over x. So now you can cross out the x on the top with the x at the bottom. And you see that when x, note that when x goes, not 0, sorry, infinity, when x goes to infinity, then b over x and d over x are 0. Because a number divided by infinity is 0, right? Like 1 over infinity. Do you understand why it's 0? A number divided by infinity is 0. Do you understand? Oh no, if it's not clear, I can explain it. So imagine like 1 over 100, 1 over 1,000, 1 over 1 million. So this becomes very small number, right? 1/1,000,000 is close to 0. So that's why we say that 1/infinity is 0. Okay. So the limit is 0. That means it approaches 0. So b/x, as I said, approaches 0. b/x approaches 0. So the only terms that are left are a and c. So this limit, when x goes to infinity, is equal to a/c. So that means the horizontal asymptote is y equal to, so y equal to a/c is the horizontal asymptote. Okay, so the summary is x equal to minus d/c is the vertical asymptote. This is the vertical asymptote. And y equal to a/c is a horizontal asymptote. Now, an example. So f of x equal to 2x plus 1 divided by 2 minus x. So what is the vertical asymptote first? So the vertical asymptote is x equal to 2, right? What is the horizontal asymptote? So remember, when you have ax plus b divided by cx plus d, the horizontal asymptote is a/c. So the coefficient of the x on the top, which is 2, divided by the coefficient of the x on the bottom, which is minus 1. So it's minus 2. So the horizontal asymptote is y equal to -2. So once you have the vertical and horizontal asymptotes, so x equal to 2, so this is x equal to 2, for example. And y equal to -2. Okay. Now, how we have these asymptotes. Now, how we can draw the graph? There are two possibilities for the behavior of this graph when you approach to the vertical asymptote. The behavior is either like this. I mean, these are the two possibilities that I'm saying. It's either like this, or let me draw with another color, or it could be like the green one. So it's either like the purple or the green. So which one we have for this function? Green. Why? So if x is greater than 2, for example, say 2.1 or 2.5, then what is f of x? if x is greater than 2, for example, 2.1. So f of x is on the top, you have something like 5 divided by negative number. So if x is greater than 2 a little bit, y would be negative. So that means you have like the purple one. So when you approach x equal to 2, from the right hand side, you have negative infinity. When you approach x equal to 2 from the left hand side, you get plus infinity. So that means the graph, I will explain more, but let me just first draw it. So the graph should be something like this. Yes. So, and the reason is because the limit of this function, when x goes to 2 from the right hand side, I mean, the limit is not a part of our course. It's usually in calculus. But I can just tell you, it's not a very difficult or deep concept. So limit of this function 2x plus 1 over 2 minus x. When x goes to 2 plus, 2 plus means something close to 2, but greater than 2. So for instance, 2.1. No, it's not equal to 2, because when you have 2, then the denominator is 0. But something close to 2 and greater than 2, like 2/2, 2.1. So this is equal to plus infinity, sorry, minus infinity. The reason is because the denominator is negative, the numerator is positive, right? And the limit when x goes to 2 minus is plus infinity. So x goes to 2 minus is basically this part, you see. This is x goes to, this part is when x goes to 2 minus. This part on the right-hand side, it's when x goes to 2 plus. And at x, when x goes to infinity, the graph approaches the line y equal to negative 2. That's the horizontal asymptote. When x goes to infinity, the graph approaches the y equal to minus 2 here, you see? Or also from negative infinity. So now, is it clear for you? Or let me ask you, can you draw the graph of any rational function of this form that I gave you? Can you do it by yourself? Okay, so very good. Now, one thing that I have to mention is the definition of even and odd functions. even versus odd functions. So a function f is called even. Do you know what is the meaning of an even function? If for any x in the domain, f of x is equal to, or f of minus x is equal to f of x. And it's said to be odd So you see, some functions are even, some functions are odd, but some functions can be neither even or odd. It's not like any function is either even or odd. There are some functions that are neither even nor odd. So basically, it's not like only we have these two categories. Okay. Oh, sorry, minus. F of minus x is, sorry, there's, I dropped the negative. So for the odd, f of minus x is minus f of x. So if f of minus x is f of x, it's even. If f of minus x is minus f of x, is odd. Can you tell me simple example of even function? No, f of x equal to
X equal to
So-
2 squared. And then.
you mean x squared?
Oh,
X squared, yes, x squared is an even function. So examples of even function. So f of x equal to x squared. Why? Because f of minus x equal to minus x squared, which is x squared. So f of minus x is equal to f of x, right? Another example. Maggie, you tell me. Absolute value. Very good example. F of x equal to absolute value of x. Again, f of minus x is absolute value of minus x, which is the same as absolute value of x. And then Michelle, you tell me another example of an even function. There is a very simple function which is even, and you didn't mention. X to the power 4 is good, but there's something very simple. Any constant function is also even. So for example, f of x equal to 10. any constant function actually is even. Or as you said, f of x equal to, because when the function is constant, then f of x is 10 for any x, including f of minus x, right? So f of x equal to 4, it's even because f of minus x is equal to minus x to the power 4, which is the same as x to the power 4. Constant function, f of x is constant. Like you have
Always the same number.
yes, this is for example y equal to 1. It's always constant. For any x, f of x is 1. So what is the common attribute of these functions? So there is a common geometric attribute of this function, of all of these functions. Let me draw their graphs so that you can see. So I draw a little graph for each of them. So f of x equal to 10, it's constant, for example, it's like this. And x to the power 4, it's something similar to the quadratic, but it's sharper. Now, what is a common attribute of these graphs? They're symmetrical along the y-axis. So you have symmetry along the y-axis. You see? So you have symmetry or symmetrical. Some examples of odd functions now. Alex, can you tell me an example of an odd function? So for example, f of x equal to x. So why? Because what is f of minus x? F of minus x is minus x, right? But minus x is minus f of x. Because f of x is x. So minus x is minus f of x. So it's odd. What else? F of x, Liana, another odd function. Any odd power of x, basically. Like x to the x cubed, x to the power 4, 5, 7, any odd power. So x cubed. F of, now, what is f of minus x? F of minus x is minus x cubed, which is equal to minus x cubed is minus x cubed, which is minus f of x. So any odd power like f of x equal to x to the power 2k plus 1. And also it's obvious that any even power of x is even. But if you combine them, then you cannot say it's even or odd. Sometimes it's even, sometimes it's odd, sometimes neither. So be careful. Sometimes, so for example, a function. So let me tell you another example of odd. Another odd function is f of x equal to 1 over x. This is also odd. Because f of minus x is 1 over minus x is minus 1. Okay, so sometimes is a remark. Sometimes we have a function that is neither even nor odd. For example, f of x equal to x squared minus x. So what is f of minus x? F of minus x is minus x squared minus minus x. So f of minus x is x squared plus x. So this is not f of x. So this is not equal to f of x, right? Obviously. So it's not even. So first, it's not even. And also, it's not equal to minus f of x. So let me compute minus f of x. What is minus f of x? Minus f of x is minus x squared plus x. So you see when you compute f of minus x, it's not equal to f of x, nor equal to minus f of x. So it's not even, not odd. Right? Okay. So another topic I want to tell you is to compute some limits at infinity. So suppose that I have a function, a rational function, but not first order. A rational function could be more complicated. For example, on the top, you have, so what is a rational function? On the top, you have a polynomial. You also have a polynomial at the bottom. And you want to compute the limit of f of x. So how to compute the limit of f of x as x goes to infinity? So I can prove this in each case, but I can also tell you the summary of the result. But I can explain to you why this results are true. So don't worry. So let me just tell you the result, the summary of the result. So there are 3 cases. So so you see, first of all, the degree of a polynomial is the highest order power. Basically, highest power or the top exponent. The degree of a polynomial is the highest exponent in that polynomial. So when I wrote these 2 polynomials on the top at the bottom, the degree of the numerator is n, the degree of the denominator is m. Okay. So, but the degree of any polynomial is just the top power exponent of x that appears in that polynomial. Now, there are 3 cases. The first case is when n greater than m. So that means the degree of the numerator is bigger than the degree of the denominator. Then the limit, in this case, the limit of f of x goes to infinity is either plus infinity or minus infinity. Basically, the limit at infinity is infinity. So now either plus or minus infinity. So the second case is when n, the degree of the top is less than the degree of the bottom. So in that case, if the degree of the denominator is bigger, then the limit is 0. So here you can say that if the degree of the denominator is 0, is bigger, then you have a horizontal asymptote, y equal to 0. So y equal to 0 is a horizontal asymptote. And the third case and the last one is when n is equal to the m. So the degree of the numerator is equal to the degree of denominator. If n is equal to m, then the limit of this, let me write it again, an x to the power n plus a1 x plus a0 divided by bm x to the power n plus b1 x plus b0 as x goes to infinity is equal to an over bm. But remember that n and m are equal here. No, not sorry, n and m are equal, not a and m bm. So the degree of the top is equal to the n and m are equal. So here we also can conclude that y equal to an over b. So because a and n, I can also say bn, but that's fine, is a horizontal asymptote. So you see, for two of these cases, you have a horizontal asymptote. So either the degree of the denominator is bigger or equal to the degree of the numerator, then you have the horizontal asymptote. So examples. So for example, the limit of x to the 4 plus so here the degree of the denominator is less than the degree of the numerator. So here the degree is 4. The degree of the denominator is 3. Now, what if you have limit of like x squared minus 2x plus 5 over so in this case, what is the limit? So the degree of the denominator is bigger now. So if the degree of the denominator is bigger, the limit is 0. And if the degrees are equal, for example, now the degrees are equal. So both are 4. So now the limit is just 3 over minus 1. Okay, so when the degrees of the denominator and numerator are equal, so the limit at infinity is the top coefficient of the denominator of the numerator divided by the top coefficient of the denominator, like 3 and minus 1. Any question so far? Yes.
Because it can either be positive infinity or negative infinity.
That's a very good question. So that's a good question. So when x goes to infinity, so the top term on the numerator is x to the power 4, right? And because x to the power 4, the coefficient is positive. So x goes to infinity is positive infinity. But you can also ask that what is the limit when x goes to negative infinity? So when x goes to negative infinity, again, it's positive infinity because you have x to the power 4. Yeah, but the cases that we are interested in are these two cases where the limit either is 0 or a number.
So if the exponent is even, that goes to.
No, it depends. So for example, let me tell you. So first of all, these examples are clear. So here, the first one, then I'm looking at the limit x goes to plus infinity, which is infinity. Now, why it's positive infinity? So the reason is, so let me write this again. Minus 2x plus 1 divided by 2x cubed plus 1. X goes to plus infinity. Now, first of all, it's infinity, but the question is it positive or negative? So you see on the top, when x goes to infinity, the top is positive. When x goes to infinity, the numerator is positive. You agree? So when x is a very large number, the numerator is positive. Denominator is also positive when x is a very large number. So that means the whole thing is positive. So that means this is positive infinity. So for positive infinity, we usually use this infinity. So when I write infinity, I basically mean positive infinity. Okay. If I mean minus infinity, I write minus sign. Okay. Now, what is the limit when x goes to negative infinity? So again, you look at the, so again, the limit is infinity, but it could be negative infinity. Now we just need to find the sign. So again, look at the numerator. When x is a very large negative number, the numerator is negative. You agree? So positive, sorry. The numerator is positive because of the x to the power 4 term. So you look at the leading term. Because of the x to the power 4 term, so that x, when x goes to negative infinity, is positive. But the denominator is negative. Because you have x to the x cube. So that means that you have negative infinity. Okay. You look tired, Michelle. Yeah. Okay, so that was about the limit. What else I wanted to say about okay, so but this is easy, but let me quickly tell you, you probably know this, but if you have a polynomial, so if you have a polynomial, so we want to draw the graph of a polynomial. If we have a polynomial and if we factor them, like f of x equal to x minus 2 times x minus 3, if you have the polynomial in factored form, then you can draw the graph. Basically, once you know the x-intercept, all of the x-intercepts, and you can repeat this for higher ordered polynomials, like of degree 3. So, but here you see there are two possibilities, x equal to 2. 3, and let's say 5. So you can either have like a polynomial like this, or you could have something like the purple one. But which one is the case? I mean, it's easy to know, to determine which one is actually the graph. For example, you can determine the behavior when x goes to infinity, when x is a very large number. So when x is a very large number, f of x is positive, right? When x is a very large number, f of x is positive. So that means f of x for large number goes like here. So that means this one actually is the graph. This guy is the graph. And again, the reason is for x very large number, f of x is positive. So eventually y goes up. Eventually it goes up. And for very negative numbers, like large negative numbers, f of x is negative. So it eventually goes down from on the left side, on the left side. Okay, guys? Okay, so we take a break, and I want you to work, if you finish the exercise that I gave you yesterday, go and open assignment 2 on the website. Yes. And do the assignment 2. The due date is tomorrow. Yeah. So we will go resume at 2 p.m. and you can ask questions. So when you come back, I really want you to ask your questions. So I prefer to discuss your questions. So you can ask the questions about the assignment problem or any question that you have, okay? I can help you.
Can?
Yes.
Oh, you just can't.
I will help you. Don't worry. Okay. So it's a break time and we will resume at 2.